Good afternoon to those of you joining us in the room for Ignite, and for those of you joining us digitally, thank you for tuning in to learn more about Windows development for business. My name is Eliana Castillo. I work in product marketing at Microsoft for Windows Developer Team with a focus on local AI enablement.
Hi everyone, I am Aditya Ramnathkar, also working in product marketing for the Windows Developer Platform team with a focus on agentic workflows and developer experiences.
Let's start by grounding ourselves in the sheer scale and influence of Windows as a development platform. According to the 2024 Stack Overflow Developer Survey, Windows is the most popular operating system for developers for both personal and professional use, with nearly half of professional developers choosing Windows as their primary platform. And with nearly 1 billion customers on Windows 11, developing on Windows means your solutions can reach a massive global audience. The scale empowers you to deliver innovation that impacts enterprises, small businesses, and individual users everywhere. AI is transforming the commercial landscape at a rapid pace. 85% of Fortune 500 companies are already leveraging AI to drive innovation and efficiency. And research shows by 2030, global AI solutions and services are projected to generate over 22 trillion in economic value. We're also seeing a surge in new applications, with 1 billion apps to be built by 2028, and 40% of those apps expected to incorporate AI by 2026. And 60% of PCs shipped in 2026 will be AI capable per research. This is a massive opportunity for developers. Building AI solutions on Windows means you can reach the broadest commercial audience, tap into enterprise-grade security, and leverage the latest hardware and software innovations. Windows is uniquely positioned to help businesses deliver scale, secure, and high-performance AI experiences, empowering organizations to unlock new value and stay ahead of a rapidly evolving market. And now that we've grounded ourselves on the scale and influence on Windows, let's talk about what it can do as a development platform. This year at Ignite, we have a lot of great sessions that offer deep dives on Windows development, whether you want to bring AI agent-driven productivity to your businesses, or integrate local AI into your company's applications, or elevate your developers' productivity on Windows. This session will serve as a guide to what's possible with Windows development, how it's evolved, and help you navigate the deeper technical discussions throughout Ignite. First, let's talk about where the platform is headed next. The future isn't just about building apps. It's about empowering intelligent agents that can handle complexity for you. I'll hand it off to Aditya to explain how Windows is evolving as a platform for AI and agents.
Thank you, Eliana. As we all know, agents are quickly becoming the future of how work gets done. IDC projects that by 2028, more than 1.3 billion AI agents will be in operation. With these agentic workflows, we are moving towards a world where you simply express your desired intent and agents handle all the complexity and do it for you, allowing you as the user to focus your time on what matters the most. To see this in action, let's take a look at a real-world example of expense management. Many of us, after this conference, will file an expense report. Today, it takes a dozen steps, 30 or more minutes, and is often error-prone. With agents, it is reduced to just one sentence. So within M365 Copilot, I can simply ask the Dynamics 365 agent to gather receipts. It uses the MCP on Windows to connect to the file server, gathers all my receipts from my device without me needing to go and manually select the files. I'm able to review the expenses that it is generating, and now it connects to Dynamics 365, generates those expense lines, and also submits it just when I am within M365. I can go into my expense management tool, verify whether the expenses that they have generated are correct, and then I can tell it to submit it for approval. And as you can see, it completes the submission so I can stay focused and keep moving. No manual uploads, no extra clicks.
That's so cool. With agents, that means the entire process is reduced to a single sentence, and that means I don't need to spend tedious time filling out expense reports with fewer mistakes and getting them done quickly enough for my manager to approve them.
Yeah. And to enable such powerful agentic experiences at scale, it demands OS-level integration for security, consent, and control. Thus, we are continuing the evolution of Windows as a secure platform for AI and agents. To provide developers with tools to build AI-powered experiences, we are introducing 3 core platform fundamentals: agent connectors and on-device registry, agent workspace, and agent ID. And finally, these experiences are grounded in enterprise manageability and security controls. Let's start by diving into agent connectors and on-device registry, which is powered by MCP. But first, what is MCP? MCP was introduced by Anthropic as an open standard designed to let AI agents and applications connect seamlessly to external tools and data sources. Think of it as USB-C for AI. This means that once a tool or connector is returned to the MCP standard, it can be used by any MCP-compatible client with minimal friction. MCP uses a client-server communication pattern with standard transport, making it both familiar and extensible for developers. The protocol is already seeing strong momentum within the ecosystem and is witnessing a growing catalog of community servers. On Windows, we are taking MCP even further. Today, we are announcing public preview of agent connectors and on-device registry, powered by MCP on Windows, a standardized framework enabling AI agents to connect with apps and tools to automate routine scenarios and perform tasks for your users. Currently, there are multiple patterns for integration. Every ISV developer can create their own way of connecting agents to their apps. However, with the Windows on-device registry, we provide you with a single and standardized way to make your MCP servers discoverable to agents. Let's now take a look at the components of MCP on Windows. Developers can expose their app's unique functionality as agent connectors. These are essentially MCP servers that handle all interactions between your app and the requesting agent. Once a developer builds a connector for their app, they then need to register it in the Windows on-device registry. By default, all agent connectors in the on-device registry will be contained in a secure environment with its own identity and audit trail. You can build agent connectors for your line of business apps to connect with agents you use in your organization. All communication between agents and the local agent connectors will go through the MCP proxy, a trusted gateway to ensure secure communication. It handles authentication by verifying the MCP client, authorization by enforcing permissions and policies, and logging every interaction for compliance. And then finally, we have the MCP client, which manages this connection with the on-device registry and can list as well as activate the appropriate agent connector as needed. Along with giving you the tools to build your own agent connectors, today we are previewing 2 built-in Windows agent connectors in the on-device registry: File Explorer and System Settings Connector. Agents can use the File Explorer connector to manage, organize, and retrieve local files with user consent. On Copilot+ PCs, the connector can also perform natural language search to retrieve the exact file name. And with the System Settings Connector, agents will be able to adjust the Windows system settings like turning from light mode to dark mode, or even connecting a Bluetooth headset while keeping the user in full control. In addition to using tools like agent connectors, agents can also interact with existing software or line of business applications to complete tasks for the users. We are excited to announce the private preview of Agent Workspace, an isolated, policy-controlled, and auditable environment where agents can interact with software just like us to complete workflows in a separate desktop without disrupting your primary session. And last but not the least, when agents are allowed to use software, it becomes even more critical for IT professionals to clearly audit and distinguish between agent and user actions. And to deliver this much-needed transparency and control, we are introducing Agent ID that makes it possible to audit every action taken by the agent. This ensures every task, workflow, and change is clearly tracked, making it easy to differentiate between what agents did versus what users initiated. So far, we have seen these 3 platform capabilities: how agents discover tools, where they safely operate, and how every action is attributed. The next question is, who is in control? So now, let's take a look at the IT manageability and end-user controls we are providing in Windows. IT admins can configure basic policies for their enterprise employees to adopt and use agents through typical policy configuration channels for configuration service provider and group policies, starting with Intune in public preview. As seen in the Microsoft Intune Admin Center, IT admins can enable or disable agent connectors and agent workspace at both account and device levels. In addition to providing visibility into what actions an agent is performing, IT admins can access event logs, which capture key agent connector events, such as invocations in the workspace, errors, and on-device registry updates. And now coming to the end-user security controls, all agentic experiences are disabled by default and is only enabled when the user toggles the experimental agentic features in Windows settings. Second, in the standard security policy, whenever an agent wants to access any such sensitive information, like your files, applications, or resources, Windows will always ask for your consent. And third, as seen in this image, we are introducing a dedicated settings page for each agent, allowing users to manage file access permissions and enable the connectors an agent needs access to. And now, with these platform capabilities, we are excited to be partnering with many agent builders and app developers who are already leveraging our platform to deliver next-generation AI experiences. Let us see how Manus, an AI-powered general productivity agent, leverages MCP on Windows to enable users to complete tasks. Say you want to build a professional real estate website using photos on your device. You just need to simply state your intent. Manus asks for consent and uses the File Explorer connector to find the right files. It then uses its own computer to build and publish the site within minutes. As you can see, you get a full audit trail for transparency while you multitask. Once it is done generating all the code, it will give us a prompt to publish the website to make it live. What used to take days now just takes minutes, unlocking real productivity gains.
Wow, this is so powerful. I can just seamlessly create my portfolio, a task I kept putting off for a while, and I can just worry about the content, and Manus will take care of building the website for me. How cool.
Yeah. So get started and dive into our documentation. Learn about how to build agent connectors for your line of business apps and register them in the Windows on-device registry. We offer flexible packaging using either MSIX or MCP bundles. And if you are an agent developer, learn how to connect, list, and interact with connectors from the Windows on-device registry. To learn this in action, join our session BRK332, where we will showcase the end-to-end developer journey for building and consuming agent connectors through the on-device registry. And we have BRK333 that is happening today at 2:30 p.m., which dives deeper into the 3 platform capabilities we saw today. And if you want to discuss more, meet us at the hub in Moscone North and South. Now that you have seen how we are continuing the evolution of Windows as a secure platform for AI and agents, let us take a step back and look at what makes these experiences possible. To truly enable advanced agentic workflows, we need an AI-native platform powered by machine learning models. Aliana will now take us deeper into that foundation.
Thank you, Aditya. But before we dive into Microsoft Foundry on Windows, let's talk about why local AI. We are already seeing many developers leveraging on-device AI capabilities. Running AI locally has the benefits of privacy, security, and simplified compliance. Regulations like DMA, GDPR, and HIPAA pose specific requirements on data handling. With local model execution, sensitive data remains on-device, giving organizations full oversight and privacy. Some app deployments may have unreliable network connectivity, and local model execution removes that network dependency to enable offline AI capabilities. For workloads like audio, video, and input processing, running those models close to the hardware may provide meaningful performance benefits. And finally, not all AI workloads need to run off the cloud. Running models locally can significantly optimize costs for both developers and their companies. For example, save your cloud tokens for running large models or large-scale deployments, but run those smaller inference tasks locally on your device. What makes local AI so compelling now is that modern hardware can now run those AI workloads, whereas before we were very reliant on the cloud. Developers can tap into the GPU for those high-performance tasks, like running language models or real-time image processing or training. You also have the NPU on Copilot+ machines, which are ideal for power efficiency and specialized AI workloads. And last but not least, the CPU ensures your app can reach the widest range of devices, supporting lightweight inference everywhere. When we think about enterprise specifically, there are lots of great examples for how these organizations are transforming their businesses with local AI, and they're inspiring to see across productivity, operations, security, and many other areas, taking full advantage of the full Windows ecosystem. Microsoft Foundry on Windows is a unified, secure platform supporting the full AI developer lifecycle, from model selection, fine-tuning, customization, to deployment, and while enabling execution across the GPU, CPU, and NPU. As an enterprise developer, there are several ways to incorporate local AI into your application. The fastest and easiest way to integrate local AI into your application is to use Windows AI APIs. Developers can leverage some of the same Windows Inbox models powering AI experiences on Copilot+ PCs through ready-to-use APIs. And these models are optimized for the NPU to offer low latency and performance without the model deployment overhead. We have task-specific APIs ranging from text intelligence through our PhiSilica model and to image manipulation. And we recently introduced 2 new APIs, Video Super Resolution, aka VSR, to upscale low-resolution streams, and Stable Diffusion, also known as SDXL, for high-quality image generation, all while running locally. And if you're curious or want to get started with Windows AI APIs, a good way to get started is through the AI Dev Gallery, which is available through the Microsoft Store. I have the AI Dev Gallery here, and as you can see, the AI Dev Gallery is basically a sandbox for us to instantly try out different features, like, for example, text generation, or OCR, which is optical character recognition, aka text recognition. As you can see, I can select text. And if I like a particular AI feature that I see in the AI Dev Gallery, I can actually copy the code in order to enable that API, or I can export that as a Visual Studio project. I won't do that here, but you might wonder, how would you use this device, or use this specific, yeah, okay, cool. All right, so just switching here. All right. Let's pretend I built this inspection report app for a client, and occasionally my client needs to process images like this one shown here, like an inspection report shown here, into the text. So I'm going to create a report. I'm going to grab that image, and it's going to use the OCR API, that text recognition API I saw in Dev Gallery, in order to transcribe that text automatically into this app.
That's really convenient.
Yeah, and the best part is it runs locally. So you can kind of see here there was a blip in the NPU. It ran pretty fast, actually. That's really good. It ran pretty fast as well, so it was running locally. And because I used a Windows AI API, I was able to leverage the Inbox model already on the Copilot+ PC. So there was no model overhead to deploy that text recognition API in my app. And then if my client won't have to rely on the cloud if they're like in an area that has bad network, like if they're in a concrete building or a remote workspace, they can still continue transcribing these reports or these images into text. But this is just one example of how how a developer could use the Windows AI Dev Gallery to their advantage for enabling Windows AI APIs. All right, go back to the main. Oh, it's not moving forward. All right. So Windows AI APIs also offer customization options to deliver smarter, more relevant outputs quicker. App Content Search enables secure, content-aware search grounded in your organization's data. This approach ensures rapid access to relevant information while keeping content sensitive content secure, like company data, for example. And then semantic search goes beyond traditional keyword matching, facilitating search by meaning and context. This is valuable on commercial applications managing complex data sets, as it unlocks deeper insights and connects users with the information needed to drive productivity and innovation. Oh, sorry about this. Well, developers can also use low-rank adapters to fine-tune our text intelligence model, like PhiSilica, for their organization's unique workflows, whether it's automating ticket generation or adapting outputs to industry jargon. Let's see that in action using AI Dev Gallery. All right, I'm gonna go back to my demo device over here. Okay, so I have here an HVAC inspection report for an administrative building. And in AI Dev Gallery, I can actually take this report and go into this sandbox for PhiSilica with LoRa. So in AI Dev Gallery specifically, I have loaded this LoRa adapter, which is trained to prioritize safety work. I have this inspection report, and I need to, let's say I have a client who wants to be able to process tickets really quickly in order to focus on safety reports. So there's a lot of text here. And on top of that, their tickets to do the safety work need to be like under 500 characters. So I'm going to go ahead and paste that here. And I'm going to hit Generate All. And you can see here that the LoRa adapter, with the adapter, it is creating a quick, concise ticket in order to, and it focuses on the safety work. It's not outputting all the text. Whereas without the LoRa adapter, it's
generating a much longer.
It's generating a much longer. It will not fit that 500 character limit, and also it's just kind of giving me all the data it can based off of the original report. So yeah, you can think of LoRa as a plugin that modifies the base model's outputs, and the base model in this example specifically. The base model in this example specifically is PhiSilica. So it's great for general purpose text intelligence, but instead of retraining that larger PhiSilica model to focus and prioritize safety work and format tickets, which can take time and incur significant cloud costs, I only need to train the smaller LoRa adapter for my specified task. And this is a high-level example of how Windows AI APIs and customization can be useful in a business solution. And I would highly recommend checking out BRK 333 and Lab 585 to learn more. And just as a heads up, I was offline when I was doing this, so all of this was running locally on my device as well. All right. Let's say you don't want to utilize our Windows inbox models, but you want to use an open source model. Maybe your app is already running on existing common model through the cloud, for example. That's where Foundry Local comes in and makes it easier for developers to access a large collection of open source models and enable them to run off of the cloud. And so by running models through Foundry Local, it also guarantees that these models have been pre-optimized for Windows to run across the GPU, CPU, and NPU. And you can see here what we currently support as far as Foundry Local. We have GPT-OSS. We have Whisper, which is a new one that got recently launched. And let's see this in action. So I'm going to switch again to my demo device. All right. The quickest way to interact with Foundry Local is through the command line interface, which can be quickly installed using this winget command, and which is a nice teaser to what Aditya will talk about later. But I have already installed Foundry Local on this machine, so I can go ahead and hit Foundry Model List, and it'll list out all of the models that can run on my device. The CLI can actually detect what hardware you have and list the relevant models from the cloud catalog that are compatible with your PC. So I'm running a Qualcomm Copilot Plus PC, so it'll list models that are compatible with the NPU as well as the CPU. If I do Foundry Cache List, it will list models that are already downloaded to run locally. And you'll see that I already have this 154 model in my local cache. And let's say I want to quickly try out that model. So I'm going to do Foundry Model Run ID, and it will load that model. I added that -- verbose at the end so that I could look at the performance. And while we wait for it to load, I have a dad joke for you, Aditya. Why do you think the PC got cold?
Maybe let's try asking that to the model instead.
Well, if anyone has any any suggestions, I'm going to wait here for that model. But I do just want to point out that, yeah, so the idea behind Foundry Local, it makes it easy for a developer to find out what model will run on their PC, gives a full list, and again, kind of simplifies that process. Oh, cool. Okay, so now,
Let's try asking something.
yeah, let's try asking it that dad joke. Why did the PC get gold? Answer this dad joke, please. Why did the PC get cold? And it's thinking. Because it left its windows open. And you can, yeah, great one. And you can also see at the end, it shows the number of tokens, etc.
That's cool. So keeping the dad joke aside, how do I actually use Foundry Local in my app?
That is an excellent question, and I will answer that with a switcheroo. Okay, so let's say I'm a dev who built an application that handles financial aid requests, and I use models that originally ran off the cloud. I want to use a model like that 5.4 from earlier to process requests quickly. But I also want to run inference locally because of the sensitivity of that data. So similar to that command line interface you saw before, you can see what models are available for download from Foundry Local. And you can also see models that I have cached locally. So looking at the what I had before, you can see 5.4, 5.4 mini, Qwen. And in the same GUI, you can see those same three models. So I'm going to load that 5.4 CPU because it did a great job with that one dad joke. It was really fast at answering it. And now you can see that I can now run that model locally. So the way it works is that Foundry Local has an API that can tell my app to run 5.4 from the local cache. More technically speaking, changing the REST endpoint to a local host. And now that my app can use 5.4 to locally process these financial aid messages, I can now fill out these student profiles based on the content of their messages up here. So you can see that it's filled out, it's looked at a message and it's filled out the forms. And this is just one visual example of how Foundry Local enables AI to run from the cloud to the edge. I also highly recommend checking out BRK 199 on Thursday to learn more about Foundry Local. All right. If we go back to our stack diagram. And at the foundation of Microsoft Foundry on Windows is Windows ML. This framework enables developers to bring their own custom model and streamline deployment across the GPU, NPU, and CPU. Think of it as a hardware abstraction layer. Let's say your company has built an app that uses a custom AI model, and maybe it's trained off of that proprietary data. Windows ML makes it so you don't have to create multiple versions of the app to support different silicon vendors like AMD, Intel, AMD, and Qualcomm. Microsoft also works closely with our silicon partners to ensure updates to their hardware don't break your models, and everything is tested for accuracy and reliability. In the interest of time, I can't speak more on Windows ML, but we have a great breakout session tomorrow and some labs that dive deep into the benefits of Windows ML, which is already for use in production apps. Like I said earlier, Microsoft Foundry on Windows provides different ways of integrating local AI into your developer workflow, with documentation and resources available to get started. And if you're going to take pictures or take screenshots, this is a great one to take a picture of because we have a lot of great sessions covering each layer of the stack, and we have some labs for a hands-on experience. Or if you want to come chat with our experts, we're going to be available at Moscone North-South Hub. And while agents and local AI represent the future of Windows, it's the developer tools that make this innovation possible. I'll hand it off to Aditya for a closer look at the developer productivity on Windows.
Thank you, Aliana. So whether you're building an app on or for Windows, we give you a suite of developer tools like WSL, Winget, Terminal, and PowerToys that help you code with less toil, more joy, and improve your productivity developing on Windows. Today, let's take a closer look at Winget and WSL and understand how they can help you elevate productivity for developers in your organization. How many folks here have spent hours just setting up their developer environment or see their IT admins going through this tedious setup process? Yes, it's a pain we all know. That's why we are obsessed with making ready to code a reality in the fewer steps. With Winget, the native Windows package manager, you can discover, install, upgrade, and configure applications on Windows. And with the new Winget configuration, without taking any manual steps, you can go from 0 to code ready in minutes and not hours, depending on the type of developer environment you're trying to set up. Winget configuration has now been updated to support Microsoft Desired State Configuration v3. It is a declarative configuration platform using which the state of a machine is described in a format that should be easy to understand even if the reader isn't a subject matter expert. Plus, it keeps the script-level logic separate from the environment definition, making it easier for IT admins to manage these files. And if you make your line of business application DSC v3 enabled, you can export and import settings through Winget configuration. Let me show you how easy this is. So switching to my machine, as you can see, there are no apps running. I go and open terminal. I'll zoom it a bit so it's visible. And then I now want to generate a configuration file based on the applications that I have installed on this device. So I go and run the command winget configure export --all --output, for example, ignite.winget. So --all --all instructs it to include every discoverable element in scope. Output provides the name of the file to generate. Once we run this command, as you can see, it fetches all packages installed through Winget that can be mapped to a source. Any package setting supported by DSC v3, it will also be exported. And even your key Windows settings like dark mode or taskbar alignment and developer options will also be captured. As you can see, it is currently exporting those. It will then write all of that into a DSC v3 compatible YAML file, which is essentially a snapshot of your environment. This isn't just a list of commands, it's a configuration as a code. Once the file is generated, you can check it into source control and apply it on any other device of your choice using one command that we'll do next. So let's give it a minute, and as you can see, the configuration file was successfully exported. I now go to my folder and see what the file has been generated. So as you can see, we have Ignite file generated here. I open that with Visual Studio. Zoom it a bit so it's visible, and you can see all the resources that it has generated. So let's say that now I am an IT admin, and I want to set up a host of devices in my organization. I want to change some settings. Let's say for this demo, let's tweak some of the Windows settings over here. I change dark mode to light. I do taskbar alignment as middle. I'll change app color mode to light as well. And just so this file executes a bit faster, I'll remove all the resources beneath it. I'll also go and remove the admin settings as well as user settings so that this can run a bit faster now. So currently we have the Windows settings. It depends on the run command. We have this resource over here, and it depends on package. We have that resource. So this file looks good. I think it is good enough that I can now export it to my demo, like all the devices in my organization, and help set that up. So let's go back to terminal and try running this configuration file. So to run it, let's type the command winget configure ignite.winget. So under the hood, Winget hands the file to Microsoft DSC v3 and runs each resource through a specified cycle: get, test, and set. It reads the current state of the machine, compares it to what's declared in the YAML, and only applies what's missing or out of sync. If something already matches, it skips that. So now it is giving me a prompt to confirm whether I want to make those changes and apply that to my device. So I'll enter Y and press enter. So you can see it gives me a prompt. I click yes. And now it is going and applying all those configurations to my device. So as you can see, it is now applying the Windows settings. And with that, we have the taskbar, which was aligned to middle, and the color mode changed from dark to light, which means that this configuration file was executed and was successfully applied. Isn't that cool?
Yep, very cool.
So this configuration file is idempotent, safe to run anywhere, and gives you a repeatable, auditable setup. So back to the deck.
Yep.
Okay. So to summarize, Winget configuration provides a single and repeatable command to set up and replicate development environment. It also supports Microsoft DSC v3, which is cross-platform and language agnostic. For IT admins, DSC v3 enables controlled, scalable enterprise application management. You can now configure a single device exactly how we did, and then export a file and use it to scale setup across devices in your organization. And on the security front, Winget supports Entra ID authorization when downloading and installing packages from private sources. Thus, with Winget and Microsoft DSC v3, you get modern, secure, and repeatable configuration management, whether you are a developer setting up your own box or an IT admin managing fleets of devices. To learn more, make sure to check out BRK335 that dives deeper into Winget and how it makes developer environment setup a breeze. Now let's talk about something unique to Windows: the ability to use Linux and Windows side by side natively with Windows subsystem for Linux. Why does this matter? Many modern workloads today run in AI and cloud-native environments. They require Linux tools. With WSL, you don't need to dual boot or run a heavy virtual machine. You get the best of both worlds. You can run Bash, use Linux distributions, and even launch Linux GUI apps all from Windows. Let's walk through what this looks like. Again, moving back to my device, where we just were, I'll just close the terminal. I'll again go and... So installing WSL is as simple as running WSL -- install. I have that already installed, so I will not run that command to save us some time. But I can see the list of all the Linux distributions running in WSL with the command WSL --list --verbose. It shows that I have Ubuntu as a Linux distribution running in WSL, and the current state is stopped. So to start Ubuntu, I can run WSL -- distribution Ubuntu. And you can, it's not just Ubuntu, you can install any Linux distribution you want from the store, such as Ubuntu, Fedyan, Debian, and more. Once installed, your Linux distro appears in the Start menu. You can launch it and directly start running your Linux scripts. And also, if you noticed in the File Explorer, we have a separate Linux folder which is coming, which will save all your Linux files that you will currently use on this device using WSL. So now that we see we are into Ubuntu, let's try and install a Linux GUI app. Let's install Genome Text Editor. So let's do sudo apt install Genome Text Editor -y. I'll enter the password for the account. The Wi-Fi is working great.
Yeah.
It's installing. And as you can see, the Genome Text Editor was installed. So now I can go and just open that like any text editor which is running natively on Windows. So as you can see, I can start using this Linux GUI app. I can type something. I can also select all, and I can paste it within any other application in Windows. So with WSL, we make all of this behavior possible using WSL2, which gives us a managed VM that Windows manages for you.
That's so cool. With WSL, running Linux-based AI workloads on Windows becomes so much easier because I don't have to dual boot and I don't need an extra Linux machine.
Yep. So to recap what makes WSL powerful, first, no dual boot hassles. You can run Windows and Linux side by side and switch instantly between your favorite tools. Second, full access to common Bash CLI tools, advanced scripting capabilities running natively on Windows. And the flexibility that we give with Linux distributions, you can install Ubuntu, Red Hat, Debian, Fedora from the store, or even import custom images for your specialized needs. And with WSL2, you get a real Linux kernel with a lightweight VM, delivering faster file system performance and full system call compatibility. That means Docker, Kubernetes, and even Linux GUI apps run seamlessly on Windows, as we just saw. And this year at Build, we made WSL open source. We invite you to contribute and help us make Linux integration even more seamless and make Windows the go-to platform for modern cross-platform development. To learn more and get hands-on, we have included some great resources here. Explore the Winget and WSL documentation and visit our GitHub and developer blog for additional tools and tips. And don't miss our sessions where we'll dive deeper into the developer tools and show them in action.
All right, so if we go back to the beginning, what can Windows development do for you? It's the platform for AI and agents baked into the OS so that every experience is grounded in security, consent, and control. With Microsoft Foundry on Windows, developers are empowered to integrate local AI solutions. And at the core of it all, tools like WSL, Winget, PowerToys, and Terminal streamline developer productivity. Ultimately, Windows development lets you integrate AI with line of business apps, unlock agent-driven productivity, and elevate your team's capabilities, all on a trusted enterprise-grade platform.
As you plan your Ignite experience, we encourage you to explore the full lineup of sessions from the Windows Developer Platform team. Across these sessions, you'll find deep dives into our platform for agents, local AI development, and modern developer productivity tools, all designed to help you build, manage, and secure the next generation of intelligent solutions on Windows. And with that, thank you all for joining us today and spending your time with us. We hope you enjoyed the session and found valuable insights to take back with you. Please take a moment to share your thoughts and let us know how we did. Your feedback is incredibly important to us. On behalf of the Windows Developer Platform team, we truly appreciate your engagement and look forward to seeing what you will build next. Enjoy the rest of Microsoft Ignite. Thank you.